Okay, today I'm going to make a universal mitre gauge with the use of the W-new mitre gauge, which is of a very good quality. I already tested the accuracy, and these dents are very, very precise. So that allows me to attach standard aluminum extrusion. In this case it's 30 by 60 millimeters. So I'm going to use bolts and T-nuts suitable for this type of extrusion. So let me put it in, just make a few turns, and now we can basically enter that into the extrusion, just like so. And all we need to do now is to tighten it up. So there is some obstacle that we have to overcome, and that's what I want to show you. Okay, so these nuts for the T-slot are already in, and they are very easily tightened. However, what you will notice or discover is that there will be a gap of about 1.5 millimeters between the rail and the extrusion. So what we need to do, I will file these slots 1.5 millimeters deeper, further down. That allows me to sit that extrusion flush with the table. So let me open it again, and then we'll proceed to file the slots, and hopefully that will fix our first obstacle. Here is the extrusion, and what we want is we want the bottom, the foot of the extrusion to be flush with the mitre gauge base. So that's basically what we really want. And now I need to file 1.5 millimeters here, so that there will be no gap between the base of the extrusion and the base of the mitre gauge. I'm using round file. Okay, I'm going to stop here and go for the other side, and then we will make the first test. So again, I'm putting the bolt here. The nut that will go into the T-slot of the extrusion. And now let me put the extrusion in. It's a good sign, because I didn't have to lift it. Okay, now, and I like this design of the nuts that can go into extrusion from any location from the outside, because they are, as you can see, they are flat. They can go into the slot You don't need to slide them from here if you are using regular nut. And sometimes it's impossible because it might be already assembled with other pieces. So this is really cool. You can just put the nuts from here. And let's tighten them. So that's perfect. So that's exactly what I wanted. So now I will test it on the table saw. Okay, the great moment of truth. Let's adjust it to the table surface. So now I'm pushing it towards the table, the surface of the table. Now there is no movement. So let me tighten it up. Okay, so now there is no movement whatsoever. Now I'm going to open the short fence and I can show you how beautiful this system is, because now I can simply loosen 2 bolts, take that out, and I have the same system, which is 30 millimeters wide, and this one is 150 millimeters tall. So let's insert these nuts. Okay, and now I will adjust it to be perfectly flush with the table. Okay, so let's adjust this tall fence to be perfectly flush with the table surface. Just hold it firmly to the gauge and to the table while tightening the bolts. Okay. So that allows me to check whether the fence is square to the table, and it is. Wow, very, very good. Yep, it is perfectly square. So the next mod of my DeWalt table saw will be drilling through the aluminum hollow, which is a very thin aluminum. It does the job. It is very, very precise. However, it doesn't allow me to attach anything to it, and I want to be able to attach the stop blocks, jigs, maybe feather boards holding the material from the above, and so on and so forth. Maybe I even want to make the fence taller to enhance the precision of my long cuts. And I also can use this tall fence to make the tenons on the standing boards. So this will allow me stabilizing very tall material. So let's mark the holes to match 2 slots, because I want to make it very, very vertical and stable. So I will drill 4 holes in this hollow. So I already marked the position of the slots. Originally the fence has around 1 millimeter gap between the table and the bottom of the fence. Okay, now I'm going to mark the holes, 12 centimeters from the edge. Done. Okay, that's done. Now let's fit it together and test. And I'm going to add some support using UHMW high density polyethylene. So I'm going to cut it around here, and then we will bolt it at the back of these 4 holes, so that we can tighten the external auxiliary fences and we will not dent the thin aluminum hollow. Let's make the cut. The cut is nice and straight. So now I will drill the holes to match this high density PE plastic, and then we can use it as support for our aluminum hollow. Okay, I drilled the holes all the way through, and the bolts will be going into the fans. Okay, over here we will be using wing nuts size M6 that matches our bolts. And there you have it. So let's fit our testing fans. Okay, good. So that's how it looks like. Okay, so I slid the aluminum profile, which is 30 millimeters by 150 millimeters tall, which can be useful for me. Now I will tighten. Okay, so it's all tightened up. I decided to change the wing nuts solution to the cam clamp because I find it more convenient and faster to use. You can see that the pin is not central, so this one you can buy very cheap because it's a standard bicycle seat tightener or bicycle wheel tightener. This one is M6. Before I show you how the clamp works, this is a T-nut or T-slot nut, which is designed specifically for fitting into aluminum extrusions slots. So the M6 thread goes in here, and the beauty of this design is that we can drop it into the extrusion from the outside. We don't have to slide it into the extrusion from the end because the end might be already blocked. And as you rotate it, as you tighten it up, you can see it turns 90 degrees and doesn't go any further. So as you tighten up the bolt, it raises up to the inner walls of the aluminum extrusion slot and then creates a very strong clamp. When you open it, it goes 90 degrees left and you can pull it out again. So this mechanism makes it perfect for my table saw fans or mitre gauge fans or band saw fans system. But because I didn't like the wing nuts or using screwdriver or Allen key, I decided to use the cam clamp. It was not very easy because I had to use the scalpel or very sharp knife, and I had to trim this UHMW plastic to perfectly fit the thickness, original fence dimension plus this UHMW board gave me the perfect distance for the cam clamp. And then as I apply pressure to the cam clamp, it tightens the fence system perfectly for me. So as you can see, I rotate it, it tightens up, and then the final tightening I will achieve from the cam clamp action. Okay, so let me show you how I go about changing the fans, because it's a universal system that allows me to use tall fences, low fences, long fences. So what I need to do, I just open these cam clamps, and you can see that this is sliding out. Now I'm going to put a very long fence. So now I will tighten it up. So now it's really solid. It's not going anywhere. We can use the normal rack and pinion and fence lock as usual. So you can adjust your fence to whatever you need. So since we already have this long extrusion, I will show you how I make the long cut. Here is my plywood. I will be using the factory edge to go along my fence. Safety glasses. Okay, so the cut is done. It looks very nice. Let's check how straight is it. Here is the factory edge with the chop. So we will be looking at our cut, and it looks really straight. So that's one of the advantages of using a long fence, even if you have a small table saw like this one. By adding the long fence, you can register your material on the very long stretch. I'm going to make the cross cut. So now I'm going to lubricate the piece, and I also generously lubricate the carbide tips. Let's have a look at the cut quality. There is no burr whatsoever, there's no cleanup required. Let's have a look. Very nice. So let me check for square. Okay, very good. I'm going to cut the fence for the mitre saw. Okay, done. Let's have a look.
the quality of the cut. It's really clean. It's really amazing.
So this is it. These are the two fixes for today's video. Thank you so much for watching, and please subscribe to Tiger Carpenter, and see you again in the next video.